All right, this is my first attempt at doing this, so bear with me. This is going to be the recorded lecture for Chapter 7, which is the Earth's climate regions. Try to keep this as quick as I can. I will be posting my lecture notes online in Moodle, so please look for those. This is going to help guide you when you're reading Chapter 7. Hopefully you've read Chapter 7 beforehand, but we'll go ahead and get started. So, what is climate? Climate is the average conditions along with the extremes of location over time. So, basically think of the conditions you have seen over the course of your lifetime here in the Nogales area, and that is part of what is going to define the climate for the area. Climatology is the study of the climate and its variability, and climate regions basically are those areas that are going to contain the characteristic patterns that define a specific climate. Along with this are biomes. Biomes are going to be climatic regions on land that basically represent specific patterns and types of areas. So you have like a forest or a grassland, savannas, tundra, or desert. Basically, it's the plant, soil, and animal communities that are associated with those specific climate areas that help define the biomes. Now, as covered in Chapter 2, the uneven distribution of the incoming solar radiation, or again, insolation, which varies with latitude, is the energy input that drives the climatic systems that we see on the Earth. The principal controls of temperature, remember, are latitude, altitude, and elevation, along with land-water heating differences and cloud cover. That mixed with the hydrologic cycle provides the basic means of transferring energy and mass throughout the Earth's climate systems. Just by examining the temperature and precipitation, important relationships can be found, and I'm getting joined by a guest lecturer, I guess you can say. Needy dog. The classification of climate regions really started with the ancient Greeks. They came up with originally 3 climate zones. They called them torrid, which was areas warmer than the Mediterranean climate that they were used to. Frigid, which were areas that are colder than they were used to. And then temperate, which is basically anywhere that had essentially the same climate as the Mediterranean area, or what they would like to call optimum conditions. Now, generally speaking, when we look at classification today for the climate, there are a couple of different ways we can look at it. We can look at it in generic terms based on causative forces such as the interaction of air masses. We can also look at it through empirical data, which is going to be based on statistics or other data for specific areas. William Köppen in 1928 designed what is widely recognized today as the Köppen classification system for climate, which has 6 basic categories and regional types for climate. And those are tropical climates, mesothermal climates, microthermal climates, polar climates, highland, and desert climates. So let's go take a look at these different climates and the subclimates that are within them, going through them one by one. So let's start out with, at the equator, we're going to start with tropical climates. Now, in tropical climates, we basically see 3 specific zones or 3 specific types of climates that we can have. The first is a rainforest. Rainforests are going to be areas that are rainy all year, primarily driven with thunderstorms. They are always influenced by the Intertropical Convergence zone. So basically that band of low pressure that is along the equatorial regions year-round. Very high rainfall, very lush evergreen broadleaf vegetation. But even though they have a huge amount of biodiversity and a huge amount of plant life, the soils in the area are actually extremely poor soils. Mostly because the amount of rainfall they get over the course of the year, which is 110 plus inches, literally washes every bit of nutrition out of the soil that the plant life is unable to grab. So, you see areas today, one of the biggest problems with the rainforest is the deforestation of the rainforest due to agricultural needs. That's usually driven by the small individual farmer who is clearing plots of land to be able to farm for himself or to sell to people. The problem with that is that they're lucky if they can get 2 crops out of that land before the soil is completely depleted. So they have to keep cutting and burning areas. This just basically leaves these essentially deserts of vegetation, because even though you've got plenty of soil, you've got plenty of rain, there's no nutrition in that soil, so the soil cannot sustain any more plant life after the farm has been there. And it will take very long periods of time for anything to reestablish in those areas. The average temperature range in the tropical climates varies by about 2 degrees centigrade over the course of a year, whereas during the course of a day, they'll vary by as much as 11 degrees centigrade. So very minimal amount of change over the course of the year, and moderate amount of change during the course of the day. Now, the second type of zone that you can have in the tropical climates is the monsoon climate. Now, the monsoon climate is an area where the Intertropical Convergence zone affects the land area for only part of the year, not all of the year. So between 6 and up to 12 months of the year. But it has a definite dry season, i.e. it has a period of time where there is little to no rain. These are primarily coastal areas. Again, they're dominated by evergreen broadleaf trees to thorn forest. And the average temperature range for the year ranges from about 5.5 degrees centigrade, and precipitation is approximately 105 inches of rainfall. Now, when we go northwards from the rainforest, we will also move into what are called the Savannas, the third tropical climate. These are poleward of the rainforest. Basically, the Intertropical Convergence zone is affecting the area for less than 6 months out of the year. So what we end up seeing is basically a climate pattern where you have a wet summer and a dry winter, kind of like what we've been seeing here in the Nogales area for the last 15 years to some degree. It's basically grasslands dominated, meaning that you're not going to see much in the way of trees. The trees are going to be isolated and scattered. Those trees, though, are going to be drought resistant. Again, very similar to what you see in our region. Things like acacia, mesquites are going to be very common trees in some of these tropical savanna areas. So if you look at the savanna areas of Africa, it's thorn trees. Usually the acacia is a primary tree there. Or what we have out here, we'll call it the cat claw, although in Africa, the thorns on the acacia are much more significant than what we see out here. The annual temperature range in savannas is going to be about 4 degrees centigrade, but precipitation is going to be way, way lower than any of the other tropical zones, with only about 45 inches of rainfall a year. Now, if we move into, if we move into the mesothermal climates, these are basically going to be areas that are a little more humid. One thing you might want to look at, you can look at page 219 in your book, and there's this map of the different areas based on the rainfall patterns. That can help you understand where some of these are going to lie. And then on page 222 and 221 is the actual maps for these different climate zones. So you can see exactly where we're talking about on the Earth for these different climate zones. Now, the first of the mesothermal climates we want to talk about is the humid subtropical climate. This is basically an area that is going to have a hot summer. Most of the year is going to be dry, or it's going to have at least a prominent dry winter period. Maritime air, or air that's coming off of the oceans in the summer, is going to affect these areas, and they can be affected by frontal activity, i.e. cold fronts, the cyclonic storms we've already talked about during the winter. Precipitation-wise, they're going to range from about 40 inches of rainfall to 80 inches of rainfall a year, with the annual temperature range being 20 degrees centigrade over the course of the year. So a rather broad difference between the hot time of the summer and the cold time of the winter. They, again, these also can be affected by the mid-latitude cyclonic systems that we've talked about, the clash of different masses of air, the cold polar air coming into contact with warm, moist, tropical maritime air. This is what creates the thunderstorms in the Midwest during the springtime of the year into the early summer, also creating a lot of what we see as the tornadic activity in North America. The second type is the marine coast, or the marine west coast systems. These are on the western coast and the northern portions of the Earth, the northern hemispheric portions of the Earth. They're characterized by mild winters and cool summers. Basically, we're talking about Europe, the U.S. and Canadian West Coast. Polar air from Maritime will control the climate in these areas. They're usually mild due to marine influences, and as well as latitude. They will actually have fog, this condition of basically a cloud forming at ground level, for 30 to 60 days a year. They can have lush rainforests that are temperate rainforests, which is going to be a mix of both broadleaf deciduous trees and conifers, as well as having ferns present in the temperate areas. Precipitation is going to range from 30 to 45 inches of rainfall a year, and the temperature range can vary between 10 degrees centigrade to 20 degrees centigrade. Now, this is in contrast to the Mediterranean type of mesothermal climate, which is basically going to have a dry summer system. Basically, what ends up happening is high pressure systems that develop during the summer that are part of the subtropical highs end up blocking moisture from reaching these areas during the summertime. 70% of the rainfall that a Mediterranean type of climate is going to receive is going to occur during the winter, which changes the soil moisture, but it's usually exhausted by the late spring. So if you're going to grow things there, you've got to grow it during the winter into the spring. By the time late spring gets there, or early summer, the moisture within the soil for the plants is pretty much exhausted. In the U.S., the vegetation is basically what we call hardleaf. It's drought resistant, basically known as chaparral vegetation. Precipitation in these areas vary from about 17 inches a year to 25 inches a year, and the average temperature range can vary between 8 inches or 8 degrees centigrade a year to 18 degrees centigrade a year. When you look at the map of the world, you'll see that that type of climate is, part of the East Coast or part of the West Coast of the U.S., as well as much as Southern Europe. All right, Moving on, from mesothermal, we're going to go to microthermal climates. Microthermal climates basically can be categorized as the humid continental climate. Basically, you're going to have a hot summer, but it's differentiated by the precipitation distribution during the summer. Maritime tropical air influences what were originally forested landscapes with bordering grasslands or grass prairies. Frequently stormy. It can be affected by cyclonic storms in North America as well as Asia. In Asia, they can also see monsoonal patterns. Basically, again, monsoon is a shift in wind that brings moisture into an area, causing storms. Precipitation in humid continental climates ranges from 20 to 45 inches a year, whereas the temperature range can go between 24 and 30 degrees centigrade a year. So we see a very large swing in temperatures. We also have humid continental but mild summer climates. These are areas where the soils are going to be much thinner. They're going to be less than 90 to 100 or 225 frost-free days. In other words, the temperature of that area is going to be above freezing for between 90 and 225 days. Otherwise, it's going below freezing the rest of the year. It tends to have less precipitation than the humid continental hot summer conditions or climate, and heavier snowfall. Precipitation tends to be between 20 and 25 inches a year, with the annual temperature range exceeding 30 degrees centigrade. So really high temperature changes. Then we move into the third of the microthermal climates, which is the subarctic. Subarctic is 10 plus inches of precipitation, so we're right around that idea of a desert almost. In some sciences, especially geology, we consider a place to be a desert if the amount of rainfall precipitation is 12 inches a year or less. So 10 inches a year is technically a desert from a precipitation standpoint. Typically in subarctic climates, you have what we call boreal forests, or basically evergreen or conifer forests, so pine trees. The soils tend to be very thin because we don't have the conditions necessary to create thick layers of soil. And underneath that soil, or just below the surface, you may find permafrost, this idea where you have ice within the ground that is frozen permanently or basically year-round. Now, in subarctic conditions, the temperature ranges go to, on an annual basis, swings of 40 to 60 degrees centigrade a year. So during the course of the year, one part of the year can be as much as 60 degrees centigrade colder than the rest of the year. So you could literally, you're talking about 0 to 100 degree average temperature for the days in change from one part of the year to the next part of the year. Next up are the polar and highland climates. We're going to kind of combine these because highland really refers to mountaintops. And if you get up a mountaintop that's high enough, it's going to have a climate that is basically the same as being at the poles. So they kind of combine together. The first of these we want to talk about are tundra. Tundra tend to be snow covered for 8 to 10 months out of the year. So we're up in the Arctic circles basically. They never warm above 10 degrees centigrade or 50 degrees Fahrenheit. Vegetation in tundra areas tend to be stunted because they have a very short growing season. If you get too far above the ground, the temperature can get to be very, very cold with a lot of wind chill problems. And so the plants are going to tend to hug the ground to try to stay near what warmth is generated by the sun during certain parts of the year. What vegetation you do tend to see tend to be sedges, which are kind of like a grass, mosses, lichens, and some flowering plants. The second type of climate system we have in there are basically what we're going to call the ice caps and the ice sheets. We're going to merge those two together. Basically, the difference between ice caps and ice sheets just tends to be how much area is covered, as we'll see in a moment. But basically, these are areas that are covered by ice year-round. Ice caps are smaller than ice sheets. Ice caps usually cover less than 50,000 square kilometers, or about 19,300 square miles. Ice sheets are larger, but again, covered with ice all year round. Then we have the polar marine climates. These are more moderate than other polar climates. The lows are not usually going to go below about -7 degrees centigrade or about 20 degrees Fahrenheit, but they're not going to be as warm as tundra. So it's kind of an in-between area for ice caps and tundra. Then we have the desert climates. Desert climates, we see vegetation as typically going to be what we call xerophytic, basically drought resistant. These are plants that are evolved to handle a dry climate. So instead of having broad leaves that are fleshy and or thin and can give off a lot of water vapor, their leaves are going to tend to be, if they have leaves, they're going to tend to be waxy, they're going to tend to be hard-leafed, or they will actually not even have leaves. The rest of the plant, sort of like cactus, it's the body of the cactus that does its photosynthesis. It doesn't have leaves. So the plant can be adapted to not have leaves and instead be able to deal with dry conditions. Stream channels have plants along them that are phragmites. Basically, these are water well plants. They have deep roots that seek water. So a mesquite tree is a great example of this. If you look at a mesquite tree, it has two basic root systems. It has the surface roots, which go out along the surface of the ground seeking nutrition and water. Those can extend out almost twice the width of the canopy. Then it has the taproot. The taproot of a mesquite tree can be 2 to 3 times deeper than the tree is tall. So it really seeks water. In fact, not much seeks water better than a mesquite tree in the Arizona deserts than saguaros. Most desert climates are going to be between 15 degrees and 30 degrees north and south latitude, where we have subtropical high pressure cells that dominate. Basically, it's the subsiding, sinking, stable air that it has low relative humidity. As that air sinks, it heats up. As it heats up, its capacity to hold water greatly increases, causing the air to become essentially drier on a relative scale. But that's not the only place we can have deserts. We can have polar climates can be deserts simply because of the amount of rainfall they get. Again, getting that difference between how we define a desert based on rainfall and how we define a desert based on its climate system. We can also have tropical and subtropical hot deserts. These are going to have an average temperature above 18 degrees centigrade or 64.4 degrees Fahrenheit. Generally speaking, these are on the western sides of continents. Basically, the rainfall is going to be between 0 and 14 inches a year. 12 is usually the normal cutoff. But basically, these are going to be caused in part by the fact that as the moisture is moving from the west to the east across the land, it's being wrung out. You're having the moisture is being taken out of it, and by the time you get to the western edge of the continent, those mountains have really just wrung out that air. A lot of those deserts can also be what we call rain shadow deserts, because if you look at especially North America and South America, we have a lot of mountains that basically do this. There's also the mid-latitude cold deserts. This is typically actually what we call the American Southwest, the Gobi Desert and others. They average about 6 inches of rainfall a year, and the average temperature is around 14 degrees centigrade or less during the course of the year. Then we have the areas that are not quite really deserts, but they're still arid regions. This is going to be what we refer to the steppes or grasslands, basically. We have the tropical or subtropical hot steppe climates where precipitation is less than 24 inches a year. And generally speaking, these are going to be closer to 30 degrees north or south latitude. So parts of Arizona, mostly Santa Cruz County, we really could be considered kind of a hot steppe environment or hot steppe climate. But we're right on the cusp at 30 degrees north latitude. In fact, Nogales is about 31 degrees north latitude, which means that we could possibly be considered a mid-latitude cold steppe climate, which are going to be north or south of 30 degrees latitude. So if you're 30 degrees north latitude, we're going further north, we move into the mid-latitude cold steppes. And same thing if you're going south. These are areas that have 8 to 16 inches of rainfall a year on average, pretty close for Santa Cruz County. Depending on which climate modeling system you look at, they say it's either 15 inches or 19 inches. I like to use 17 inches as an average for us. The rainfall is from convection thunderstorms, i.e. like we have during the monsoons, and cyclonic systems that penetrate the area during especially the winter and early springs. Sounds like us also. But those are basically the climate systems. I know this was kind of rapid, leaving a lot faster than we normally do. I'm going to put together the video for climate change. Previously, the previous version of the books that we used basically had this combined with climate change, and now they have climate change as its own complete separate video, or chapter I should say. But I do encourage you to go through and look at the book. They have many of these graph systems like this telling you about the differences in temperature and climate through an area, so you can see how some of these vary over the course of the year and give you a better idea for which climates are where in the world. I think that's pretty much going to conclude for Chapter 7. Again, I'll put my lecture notes up in the Moodle for this as well. This will be linked in the Moodle, so you're watching it, you found it. I'll get Chapter 8 done and up, and then we'll get 9 and 10 done and up, and I'll see you guys on the 30th of June.